With the Lumen Learning, I forgot to say this, I did set it up so that when you click on the link in Blackboard that'll take you to Lumen Learning, it will open the site in a new window. I know some people had trouble accessing the site. I mean, the information you need, the course ID and enrollment key, they're in the syllabus. And once I set it up, once I was able to set it up so that it opens in a new window, I think for one person, it fixed the problem they had. So hopefully that'll fix any trouble you had logging on. Again, if you have trouble logging on, please contact me. Okay? I do have office hours today. All right. Here we go. Okay, so let me get back to the lecture. All right. Here we go. Now, this is what happens when you add and subtract polynomials vertically, okay? Again, it's the same idea. The only real difference, though, is that it's a little more visual. I did write out the procedure here, which is also in the textbook. We're going to take the first polynomial, right? You have one polynomial, the first one, plus the second. The first one you're going to take, you're going to draw dash columns for each term. This is something I recommend doing, adding zeros as placeholders. I mean, when we do examples, you'll see what I mean. But to me, at least, it just makes it easier when you add zeros as placeholders. Then you arrange the terms in the second polynomial. So you're going to take the second one now. Like terms go in the same go into the same columns. And again, you're also going to add zeros as placeholders if necessary. I mean, really, you don't have to do that. I just think it makes it easier. I mean, if you're doing this method and you don't add zeros as placeholders, I'm not going to mark it wrong. It's also good to keep any negative signs with the terms. I mean, you really definitely want to do that. I mean, if you were just adding, you would then combine like terms and write your answer in standard form, you know, like we did before. But if you're subtracting, you want to distribute the minus sign before combining like terms. Okay? So you want to make sure you do that. And this is just an extra note I did. Again, when subtracting, you want to distribute the minus sign before combining. Again, you'll see what I mean when we do some examples today. Also, when you're adding, what's really nice about adding is, you know, addition is commutative. So you can really add the polynomials in any order you want. Personally, the one that has more terms, I like to take that as the one on top, or the first polynomial. That's just me, though. I mean, do you have to do that? Well, no, you don't. I mean, subtraction, you don't have a choice because subtraction is not commutative. Let's do some examples to hopefully it will make it a little bit easier to process what it's saying. For instance, let's say we wanted to add this polynomial with this one. Okay, now we are adding, right? Since we're adding, it really doesn't matter which polynomial we write down first. So I just had to put something down. So I'm going to take this one to write down first. It has more terms. So each term gets its own column, as you can see. Okay, now that's the first polynomial. What about the second? Well, for the second one, again, like terms go in the same column, right? So the 7x squared, I'm going to put that in this column. The 3x is going to go in this column, right? Because these are like terms. And 1 finally goes in here. Notice there's nothing here, right? There's nothing goes in these columns. So you could leave these blank, or you can use 0 as placeholders. What I've done in the past is I would actually instead write 0 times x to the 4. just to help you remember, just to make it easier, I think some people like this better instead of just having 0. You can write 0x to the 4 or 0x cubed. That's actually what I did last semester. So you could do that if you want. But either way, you have 0 here. Now we're going to combine. In this case, we're going to add. And when we do that, we get this. As you can see, those x cubed and x to the 4th went away. Because again, this semester I was going to not write those, but might change my mind. Because I think some people like seeing these 0x to the 4 and 0x to the cube better. Someone in my last class said that. So, all right. But anyway, you combine and we get this. See, x to the 4 plus 0, x to the 4. X cubed plus 0, x cubed. Minus 5x squared plus 7x squared, 2x squared. Minus 3x plus 3x, 0. 5 plus 1, 6. Okay. Then we write our polynomial in standard form. This 0 we just leave off. So that's our first example. Any questions on this? Yes? Someone have a question? Oh, I can't see the chat when I'm lecturing, so, oh, do we have to do these both? No, you can choose which method you want. You can choose which one. Okay. Also, I think there's someone else, Brooke, I think, do you have a question or?
Sorry, I just forgot to put my hand down.
I'm sorry, what?
Sorry, I just forgot to put my hand down from earlier.
Oh, that's okay, that's okay. Also, when I'm lecturing, I can't see the chat, so please, everyone, use the hand raise feature, okay? If you have a question. But someone asked, though, do you have to use both methods on a quiz or test? No, you can use either one. I'm just showing one, I'm just showing both methods, and you could just use whichever one you prefer. I mean, I don't know if there's other ways of adding polynomials. So, although I guess using a calculator would be one way, but that's not a way we want. So, let's do another example. But again, we're adding here, right? So again, what I like to do is take the polynomial that has more terms, and I'm going to use that as the one on top. We're adding so we can do that. Now here, let me do this. This came up in my other class. So again, 5x to the 5th. That gets its own column, right? Minus 3x to the 4 gets its own column. X squared, right? That gets its own column. But notice there's no x cubed term here, right? That's missing. So I'm going to use 0 or 0x cubed if you want. Oh boy. As a placeholder. So this takes care of the term of degree 3. We have x squared. That goes here. Minus x gets its own column. 10 gets its own column. Okay? Okay. Now we have to handle the second polynomial. Okay. Well, 12x to the 4, that's going to go in this column, right? Because these are like terms. Okay. The minus 4x cubed, well, remember, this was 0x cubed, okay? As you can see. There we go. So, this was 0x cubed. So the minus 4x cubed, that goes here, okay? That's going to go here. Minus 5x squared goes in this column here, x squared. There's no x term, right? So we put 0 in as a placeholder, or 0x if you want, and 5 goes in the constant term. There's no x to the 5th term, right? So again, we're using 0 as a placeholder. You could write 0x to the 5th if you want. It's up to you. Okay. But finally, once we do this, we combine by adding, and we get this. So we have 5x to the fifth, right? Plus 0 is just 5x to the fifth, minus 3x to the 4, plus 12x to the 4, right? That's just 9x to the 4. Again, we really just add by combining coefficients. 0 minus 4x cubed is minus 4x cubed. X squared minus 5x squared minus 4x squared. Minus x plus 0 minus x, 10 plus 5 is 15. And again, we want to write our polynomial in standard form, right? So the exponents of x, the variable, are decreasing as we read from left to right. I mean, I know this, it's not written, but it's understood to be 1 the exponent here. Again, if you wrote 1 here, that's fine. Same thing with the coefficient. So we have that example. So, yeah.